I know, I know. I just wanted to go through a bit of this before we go on to the next part so that we can remember what we learnt about on Monday, okay, which was a long day, long way away. So last lesson, we started looking into this correlation coefficient, which is essentially a number, okay, that represents a graph, okay, and it's called the R value. And that value basically tells us what's the strength, what's the direction. Okay, it's automatically going to be linear because it has to be a linear graph first, okay? So we use that now to come up with our interpretation or explanation for that graph. Is it positive? Is it negative? Is it strong? Is it moderate? Is it weak? Okay? So those are the three things, and also is it linear? Make sure you write down that it's linear. You can also remember use these values as a reference point to understand what is the strength, what is the direction. So obviously if it's a negative number, I won't include that, negative number, it's going to be a negative, okay? If it's a positive number like this, it's going to be a positive of some sort. And the values, depending on where the number falls, okay, tell you what the strength is going to be. So if it's between, say for example, you have a R value of 0.62, okay, that would fall between somewhere these numbers. So that tells me that the direction is positive and it is moderate. Okay, and you can use that principle for any number that you have. All right. Also, we learned about how to put these numbers in a calculator and then find out the linear regression. Okay, which is basically what this does. This linear regression, a plus bx. We're going to get into more of it a little bit later, but this is how you find the R value, okay, on your calculator. So I'll do it really quickly so you guys remember how to. On my calculator, let's say you've got your numbers. Okay, I'm going to get rid of this. Let's say I want to find the R value for this. Okay, firstly, identify which is EV, which is RV. Remember, EV is X, RV is Y. EV affects the Y, or EV affects the RV, okay? So if you go from here, menu, number 4, number 1, number 4, and then understand which is EV, which is going to be your, I think in this case, I think we said it was hair, and then your RV is going to be height. Okay, and then from there, okay, you can see that the R value is negative 0.4. Okay, easy. Now, we've done all that, easy, not too hard to do. And then we use these as an example to find some of the R values. Okay. All right. Right, so moving on, we started on this correlation and causality idea last lesson. I didn't get you to do any work yet because I just sort of wanted to explain it to you guys in that when we do this, it's not necessarily very, very mathematical in the way that you answer the question. A lot of it is thinking logically about why a variable affects the other. Okay, so causality is that keyword where we try to think about what is causing these two variables to have a connection or maybe not have a connection. Okay, you'll see this as well here, R squared, it's not the R value. Okay, don't think of them as the same thing. All right, so here you've got two variables, tollway fatality rate on the RV or the y-axis, and then fresh lemons imported from Mexico in the EV, which is the y-axis. Now, Anthony told me, or told the rest of the class, that this graph is silly and there shouldn't be any connection whatsoever because the amount of lemons you import from Mexico should not have anything to do with the amount of people dying on the road. Okay, this is saying the more lemons there are in Mexico, the less the deaths, which makes no sense whatsoever. Okay, and that's true. There isn't a connection. Okay, but then why is it that the R squared value, which and also mean what that means is also the R value is quite high? Why is there a connection? Okay, so there's three possible explanations as to why that's the case. Okay, and these are what we use, these explanations. So if there is some sort of correlation, which is represented by the R value, remember the R value here is, this is not the R value, but I would say that a graph like this has an R value of like 0.98, just for example. It's really high. So why is it so strong and what is it negative? Well, there's got to be an explanation for it. Okay, and these are the three explanations that you can use. One is very obvious. One variable, so whichever one it is, we don't know, but one variable affects the other or causes the other to be what it is. So there is that, okay? That only works, for example, if, say, for example, I use the idea that the more hours you sleep, the more awake you'll feel the next day. There's definitely a connection there. One variable will affect the other. So that makes sense. But for some other instances, it might not be. Say, for example, this one here. Okay, fatality rate on the road and lemons. There isn't any connection. Okay, and there shouldn't be any other variable that affects it. So what that means is that should be a coincidence. So this is a coincidence, or an example, or the example of an explanation here is it's just a coincidence. Okay, they don't affect each other at all. The third explanation is there is a third variable, which we don't know what it is. Okay, but there's got to be some. So what for this example, or for this statement, sorry, there's got to be another variable. We don't know what it is exactly, but that is affecting the other two variables to be what it is. So whenever you use this as an answer, this one here, we use there is a confounding variable as an explanation. Okay, so I'll highlight those three. Oops. So this is the most basic one. We already know that one affects the other. Like that's one that we all should be aware of. The other one is it's a coincidence. There's no connection whatsoever. Okay, it's just basically a coincidence that that's happened. And the other one is a confounding variable where we don't know what the variable is, but we know that there is some form of connection as to why that is happening. Okay, so let's try and apply those three explanations to some of these problems here. So let's look at this example. For each of the following pair of correlated variables, decide what's the possible explanation for their correlation, and which is the most true, giving reasons for your answer. So for the giving reasons part, it mainly is up to you, okay? And you don't have to write a long sentence about why you think that is the case, but you are still supposed to write something, okay? Don't just write, for example, other variables. Oh, sorry, don't just write this for me. Or don't just write coincidence. Okay? Don't just write coincidence, and then don't just write confounding variable. I want you to give me an explanation as to why. Okay, so let's use this as an example. Number one, or A. Okay, according to this, the average household income and the average number of hours worked per week. Okay, so have a think about it. Is there a connection between those two? Yes, okay. So as an answer, okay, you would use this one, okay? This as an answer. So you would say the average hours worked, sorry, directly affects average income. Okay, and I would be happy with that because it's a very plausible explanation. It's one that we already understand and know. So there's definitely a connection between those two variables. Okay, what about the second one? Okay, B. Percentage of people eating beef and percentage of people killed by a lightning strike. Okay, people eating beef, lightning strike. So the more you eat beef, the more steak you eat, the more lightning strikes occur. Is there a connection there? Okay, so you would say here, the percentage of people eating beef, of eating beef, and percentage of people killed by lightning strike is a coincidence. Okay, it's just a coincidence. There is no possible way that that's probably a thing. Okay, there's no connection whatsoever. And then C, the total amount of money spent on pets and the total number of lawyers in Melbourne. Before I actually go ahead, you can go into more detail if you want. You could say, for example, I shouldn't have wrote C yet, but you could actually even add there is no connection between these two variables because the amount of beef you eat will not affect how often you get hit by lightning. Okay, you can write that down as well. That's also okay. When you look at the textbook answers, they do go into detail about this kind of stuff. Okay, but strictly speaking, you don't necessarily have to. All right, see the amount of money spent on pets and the total number of lawyers in Melbourne. Okay, so the amount of money spent, okay, on pets. So that could be like insurance, could be on healthcare, it could be, medical bills, okay, that kind of stuff, and the total number of lawyers in Melbourne, okay. Yes, they may not be totally connected, but can you guys think of maybe other reasons why they are happening? Or would you agree that there could be other reasons why that's happening? Yeah, I would say you could. There could be a reason. Maybe the lawyers all have pets, okay, and they all want to get pet insurance, okay, or maybe because everybody has pet insurance and people's pets are, for example, getting into accidents, they're getting more lawyers to come and help them. Okay, so we don't know exactly what the variable is, but you can justify by saying that it is there is a confounding variable. Okay, so you would say there is a confounding variable affecting. Okay, and then you tell me what the two variables are. Money spent on pets. Okay, and total number of lawyers in Melbourne. Okay, that's fine. I would accept that. Because we don't know what the confounding variable is, that's the point. There is something affecting them, but we don't know what it is. Okay, it's an unknown variable. But that's in one way that you could try and answer these questions. Now, because again, a lot of the scenarios you'll come across are a little bit different. The way you word it might change, but essentially, if you have these three as sort of your skeleton answers, or you refer to these three, you should be all right, okay, as one of your answers. Okay, that was it for 7E and 7D. Okay, so I'm gonna stop there now.